Now it's time to look at one last pill that you can use in your modeling efforts. This one's called Tune Model Hyperparameters. So what I've done is I went and I got my loans data. I've got a little bit more data there that I can work with, and I downsampled it 20% so that I've got about 10,000 rows coming out of this 50,000 row small sample. Then I did a little select columns. I only want those columns I'm not going to know about before I issue a loan. So here are those columns. I did an edit data. I converted a couple of these fields that were coming out as non-numeric. I just turned them into numeric fields, integers. These are integers I'm setting up. So I just changed the data type to integer. I did this one field revolving balance to a floating or a double precision number, just in case there's some non-decimal or non-integer numbers coming in on that. I did a math operation to create a binomial label value that I can use, and I'm calling this, I'm basically looking for my numeric loan status numeric to be less than or equal to -1. So the loan status goes from -3, I think, to +3. So anything below 0 basically is an indication that we might be worried about this loan. So if we can predict this ahead of time, that would be fantastic. All right. I changed my new column name, which turned out to be less than or equal to loan status numeric, blah, 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 to a new column name just so I could use it a little bit easier going forward. Now I took away I basically used all columns except loan status numeric. So I included all columns to start with and then excluded loan status numeric. So that sets my data set up for my evaluation and modeling. So I did a partition and sample, and we set up 10 folds like we would normally do. I'm using a decision forest regression and a 2-class neural network. So I've run these using a split holdout and then also a cross-validate model. Let's take a look at what our results are. So far, these models are not all that awesome. So using the split approach for the regression, I have a -r². So you may have encountered that in some of your previous modeling efforts. Even in Excel, a -r² basically says, hey, this model is worse than throwing darts or flipping a coin. So this is not a good model, and it's difficult to predict which loans will go into default. So if it were easy, then no loans would ever go into default. So we're going to see if we can improve that score by tuning our hyperparameters a little bit. On the classification, you can see we've got an AUC of 0.64, 0.65, a little bit better than flipping a coin, and accuracy of 0.93, but that is because we are overly conservative and predicting non-defaults for most all of our applicants. All right, so let's jump back to our modeling window. And let's clone this, and we will make this our tuning version. All right, so we'll save that. We will keep the partition and sample because Tune Model Hyperparameters works with folds and does its own cross-validation. So I'm going to take cross-validation out, and I'm going to bring in Tune Model Hyperparameters. So the first thing it asks is, well, which mode do you want to use? I'm going to use a random sweep. If you do select the entire grid, that will take a long time. You will get your best results this way, but it will take a long time. So I'm going to choose a random sweep, and that will give me an idea of, can I improve this model's performance? And I'm actually going to limit it to 5 runs. So it's going to try 5 times to do better and see how it does. And I will just enter my random seed there. My label column, since I gave it a nice easy name, is predicted default. So I could save that. And now it's asking you, well, what measure do you want to use? Which metric do you want to use to guide the tuning efforts? So for classification, we've been working mainly with AUC. For regression, we would use R squared. All right, so let's go ahead and use those, continue using those. And my node information, let's see, we'll go tune model, tune regression model. And we'll bring in our group information here. So I'll bring my untrained model in here. I'll bring my cross-validation folds in to my training data set. And you'll notice we have an optional validation data set. So I can actually bring in some validation data as well. We'll hold off on that for now and see when we use it, what that can do for our model. The other thing I need to do is I need to go into my algorithm, and instead of forcing it to these parameters, I'm going to allow the parameters to be set to various ranges of values. So you can see I've got values set up for the number of decision trees, the maximum depth of the decision tree, how many samples per leaf node that we allow. So I could even say, oh, give it or maximum depth of the decision tree. I could say, okay, let's give it up to 128. See what that does. All right. And give it up to 64 decision trees. And the Tune Model Hyperparameter is going to give me 5. It's going to randomly go through 5 of these and then sort the results. So I could take my sweep results. I'm going to have to use my score model. With my results data set as well. And then I can bring my scored data set into my evaluate model pill. All right, so I'll clone that, basically do the same type of thing, score, regression model. And I'll take these two and copy them over. So I'm going to tune my classification model now. And bring that into my evaluation. So like I did for my regression model, I'm going to also have to tweak the settings for my classification model. So instead of single parameter, I will allow parameter ranges to be modified. And you can see I've got different learning rates, number of iterations that I can go through. All right, so let's go ahead and run this. And we'll come back in a little bit and see how it does. Okay, our job is finished. It did take a few minutes to run. So what do we get when we run Tune Model Hyperparameters? Remember, we set our parameters so that we were using the parameter range, and we were able to make some adjustments there to give it more values or fewer values. You can add ranges there if you would like. So when I run my Tune Model Hyperparameters, I get sweep results. And what this gives me is it shows me for each run how well it did, and then it ranks the runs. So you can see here I had negative, some pretty big negative R-squareds, but remember we had negative R-squareds before, and I end up with slightly positive R-squareds. So that means there's a little bit of explainability there that I never had before, so I can use that. All right. Let's see what we got on the classification side. So we'll preview our sweep results, and we'll see we were working for AUC, so we were able to continue to improve it. So that's something to consider. If you have a tuning run where you're going through a random approach and you see continuously improving metrics, it might be worth going back and running it again, but this time allowing for more iterations as it might continue to improve the model. All right, so let's try that and see what we can do. I'm going to take my Tune Model Hyperparameters back in my design, and we'll set that to 10. And I'll do that again over here on this side, 10. And run my job. We'll pause the video and come back when we're done. While this new other job is running, I'm going to go back to this one here. And let's just take a look at the results. We saw our sweep results, but let's now take a look at the full evaluate model where we're pulling in the data set again. And we can see now we're evaluating all 10,000 rows, 10,000 plus a few, based on our 20% sample of the 51-ish thousand original rows we had. So I evaluate the model, bring up my evaluation results, and you can see that based on the combined model that is used to score the data, I actually have a coefficient of determination of 0.21763. So I'm going to put that into my results here, and we're going to call this Tune 5 iterations. So my R-squared is now 0.2176, my RMSE 0.2249, and my mean absolute error 0.1137. All right, let's see what happened for the Tune 5 iterations for our 2 class. So we'll preview the data here. Take a look at our results. Yeah, our curve definitely looks better. And our AUC is up to 0.818. Our F1 is a little worse. And our accuracy is 0.931. So accuracy has gone up a little bit over cross-validation. All right, so we're making progress. We'll see, I'll pause the video and we'll see how things look when the 10 iteration work is done. Okay, we have finished our job. Let's see what the Tune Model Hyperparameter did as we added additional iterations. And here you can see we got ourselves, we improved the coefficient of determination maybe a little bit. Let's see how that translates to our actual model evaluation. All right, so we're at 2.21763. So about the same. So in this case, 10 iterations didn't really help us. RMSE, let's see what we've got. Pretty much the exact same. MAE. Yeah, about the same again. All right, so let's see what we got for the 2-class neural and if we got any improvement there. All right, so we have AUCs ranging from 0.61 to 6.5. F scores, not fantastic. So this is a conservative model still. All right, let's take our evaluate model and see what we end up with out of that. And our AUC is now 0.818, which is about the same as it was. So in many cases, you will get about all the improvement you will just from a random run. But if your random run looks like it is continuing to improve your model efforts, it might be worth running a few more iterations just to see if it helps. All right. Okay, one last thing we can do to help our model. I've gone back into my pipeline near the top and I've removed my partition and sample that I was using to downsample down to 20%. I left everything after that with my data prep, converting my fields, creating my binomial, editing my data types, and my column names. So then after that, I downsampled here with a split data. And I decided to use a split data here so that I could keep that reserved to 80% and work with it. So instead of downsampling with a partition and sample, which just gives me that downsample and nothing else, the split data gives me my downsample here, which I'm now going to use for my cross-validation. So everything else after this partition and sample goes into Tune Model Hyperparameters, Score Model, and Evaluate Model, just like it did before. All right, so then what I did with that 80% remaining data, I took 25% of that, and I'm going to use that to score my model. So using it kind of like holdout data, but not all 80% of the holdout data, just a chunk of the holdout data. I could have used the entire 80% here. That would make the training process work a little bit longer, especially because I also added this data to my Tune Model Hyperparameters into this optional right-hand port. So that's optional tag data that it can use. And as a matter of fact, I could go ahead and score the entire model based on that remaining 80%. So I'll use that second split data just for tuning the model hyperparameter, but then I'll score the model based on the full 80% remaining. All right, so we can run that now. And at this point, we're getting a better and better feel for what our model's real life performance is going to look like. So let's go ahead and submit that, see what we get. So actually, instead of using the entire data set to score the model, let's use our same approach we've used in the past, where we're basically taking the data that we used to partition and sample to build the model, so the folds, and we'll score the model with that. And let's submit the job, see how we do. And we'll come back and see what we get when we're done. All right, let's take a look at our results. If we look at the sweep results over on the regression side, okay, yeah, we can see we're improving, and it looks like we're continuing to improve. Now, our coefficient of determination for the combined models and the data that we have used, let's take a look at that. So we're at 0.220665. And we'll call this Tune with tagged. RMSE 0.22451. MAE All right, so we've made slight improvements in all three measures in our regression model. Let's see how things worked over on the 2 class. All right, so our AUC continues to go up. It peaks at 0.6704. Accuracy, precision, learning rate. Let's take a look at our evaluation results. And our ROC curve is 0.713. So actually a little bit worse. Accuracy 0.93. And an F1 score of 0. Now let's take a look at something, because if we evaluate our actual data, let's come up here right before we've split it for the first time, and we preview the data. We see that we have 47,616 that don't default, 3529 that either have defaulted or look like they're going to. So let's figure out what that ratio is. 47,616. $35.29. right, so our positive rate, those that we're interested in, would be that divided by these two. So 0.068, so somewhere between 0.6 or 6 and 7%. All right, so let's go back to our evaluation results and take a look at them. But this time, let's go ahead and slide that slider down to 0.6 and 0.7. And we can see that our F1 score is much better than it was. Our AUC, of course, stays the same. Our accuracy is going down. All right, so this is a good example of using the threshold and choosing which measure makes most sense depending on what you're trying to accomplish. So in this case, we probably are trying to identify those that will default. And here it looks like we might be a little too aggressive with that. So here we want to find a sweet spot, and we can work with this to help define a good model and a good set of measures. Again, the best approach for this is going to be using your expected value model that we've spoken about before already in class, and you'll have a chance to take a look at and work with going forward to see what kind of threshold you want to set, which measure you think is the best measure to work with, and how to implement those in your expected results. Okay, just for fun, I ran this one more time. I turned my Tune Hyperparameters on in my classification model and switched it to F-score, which may actually be a little bit better, or you may even specify precision or recall when your positive case has a low percentage of values. If you're more 50-50, then the AUC might still be a better option for you, or if you have no idea what it's going to be. So if you've got a lower percentage of positive cases, you may want to use the F-score as your measure. So I did and ran the model, and the results I ended up getting, if I look at the Tune model sweep results, we can see that the AUC was up and down a little bit over the 10 iterations, but the F-score started to improve and continued to improve pretty well until it got up to 0.15. Interestingly, the accuracy went down. So let's see what happens when we look at the results of the model itself. So we evaluate the model, check the results here, and we see we've got a little bit more distribution throughout the confusion matrix. And as we get down closer to our actual prediction level, we're still maybe a little over aggressive in identifying potential defaults, but that may give us the impetus to bump up the interest rate or be stricter with the terms. All right, we get an AUC for this model of 0.874. Which is higher than any AUC we have had so far. We have an F1 score in this model of 0.428. So this is the combined model, which is way above anything we've had. And the accuracy in this case goes down. So we take a hit to accuracy with the hopeful result of getting a better model from a financial standpoint. So again, the different measures are useful in different ways. You want to balance them out against each other. AUC for low probability positive cases, you want to see a real steep incline in it toward the left-hand side of the curve. And then that indicates that you're going to have better results with that model for your data set. All right, I think that's enough for Tune Model Hyperparameters. I will turn you loose and let you work on your projects and see what you come up with.